Imagine spending like $50,000 to transform your luxury home into this perfectly sealed, climate-controlled vault.
Oh yeah, with the triple pane windows and the heavy airtight doors.
Right, exactly. You lock the doors, you trust the humming machinery above your ceiling to deliver the absolute freshest, purest air imaginable.
Which is what they promise, right?
Yeah, but only to realize a few years down the line that your expensive system has a fatal structural flaw. And you have accidentally turned your own lungs into the building's final air filter.
That is just a deeply unsettling scenario. I mean, it really strikes at the heart of our modern obsession with, optimizing our personal environments through technology.
It totally does.
We kind of assume that throwing enough money and engineering at our homes will just isolate us from the unpredictability of nature.
Well, welcome to the deep dive. If you are sitting in a newly renovated home right now, or if you've ever, toured a high-end property boasting a state-of-the-art air system, you are definitely going to want to hear this. Today, we're looking at a piece of writing that takes a complete sledgehammer to one of the most highly praised, expensive home technologies on the market, the heat recovery ventilator.
Right, and in the building and HVAC industries, you might actually hear this referred to as an ERV, which is an energy recovery ventilator, or sometimes simply a total heat exchanger.
So our source material today is a really fascinating, incredibly intense essay. It's titled Master Insight #383, and it was written by author Fuchi Wu, dated July 5, 2026.
And the mission for this deep dive is to critically examine this author's really paradigm-shifting argument.
It really is.
The essay basically claims that these ventilation systems, which are universally marketed as the absolute pinnacle of luxury for clean indoor air,
And energy efficiency, too.
exactly, that they might actually be a dangerous IQ tax. I mean, the author details these severe structural, biological, and even architectural flaws that challenge the very foundation of what we consider healthy indoor air quality.
But before we jump in, just a quick disclaimer. The author uses incredibly strong, uncompromising language. It's highly critical of the technology and the whole industry that markets it.
Very critical.
Yeah. So we aren't here to take a side or endorse the author's viewpoint or, dictate your home renovations. Our goal is just to impartially unpack the mechanical and biological arguments presented in the text so you can understand this really compelling perspective.
Just laying out the facts as they present them.
Exactly. Okay, let's unpack this. I think to understand why the author believes these systems are secretly harming homeowners, we first have to, understand the mechanics of what they're actually supposed to do.
Yeah, let's break down the standard definition provided in the text. At its most basic level, a heat recovery ventilator is a machine that exhausts stale indoor air outside while simultaneously drawing fresh outdoor air inside.
Right. Sounds simple enough.
It does, but the defining feature, the reason it commands such a premium price, is the energy exchange mechanism.
Okay, wait. How does that actually work? Because it's not just like opening a window and putting a box fan in it.
No, far from it. Inside the main unit, there is something called a heat exchanger core, or an enthalpy core. Picture this massive block made of alternating, tightly packed layers of these specialized permeable membranes.
Like a really dense honeycomb or something.
Yeah, exactly like that. So as your conditioned room temperature indoor air is blown outward through every other layer of this block, the incoming outside air is being pulled inward through the alternating layers.
Ah, I see. So the two air streams are crossing paths, but because of those membranes, the actual physical air never mixes.
That is the crucial mechanism right there. The physical air streams remain totally separate, but the heat energy and the moisture, they actually transfer across those thin membranes.
That's wild.
Yeah, so if it is freezing outside in the winter, the warmth from your outgoing indoor air kind of jumps across the membrane to preheat the freezing incoming air.
Oh, wow. And I guess in the summer it does a reverse.
Exactly. If it's a boiling summer day, the outgoing cool air pre-cools the hot, humid incoming air.
So it's actively recovering the energy you already paid your air conditioner to create, rather than just, venting it out into the neighborhood.
Right. That's the whole selling point.
I mean, that sounds like a brilliant piece of engineering. Why on earth does the author view this as a fundamental mistake for a home?
Well, the author's critique actually begins with a history lesson. This technology was never originally intended to create a healthy, natural sanctuary for a family.
Really?
Yeah, it was actually born from a commercial crisis. Decades ago, massive corporate office buildings were being built as these completely sealed glass towers, mostly to save on heating and cooling costs.
Oh, I've seen those. Just giant glass boxes.
Exactly. But locking thousands of workers in a sealed box led to this massive rise in what they called sick building syndrome.
Oh, right. Where workers were getting lethargic, experiencing headaches and respiratory issues because all the carbon dioxide and office pollutants had literally nowhere to go.
Yeah, the air was just trapped. So corporate developers were kind of backed into a corner. They needed to introduce fresh air to their workforce, but opening windows on a 40-story skyscraper would cause their massive industrial heating and cooling bills to just skyrocket.
So they needed a workaround.
Exactly. The HRV was developed as an industrial compromise. It was designed to reduce collective corporate energy costs while keeping the human workforce minimally functional.
Wow, okay. So the author calls this a fundamentally flawed transplantation. It's essentially taking, like, the industrial water recycling system from a massive automotive plant and cramming it into your residential kitchen to save a few pennies on your monthly water bill.
That's a great way to put it.
I mean, the scale and the purpose are just completely mismatched.
And what's fascinating here is how the author frames the economic logic of that mismatch. In a massive commercial tower, shaving a few percentage points off the HVAC load translates to, well, hundreds of thousands of dollars in corporate savings.
Right, which justifies the cost of the machine.
Exactly. But in a residential home, you are demanding that a homeowner spend tens of thousands of dollars up front on heavy machinery, complicated ductwork, installation, all to save a minuscule fraction on their monthly residential electricity bill.
The math just doesn't add up for a normal house.
It doesn't. The author refers to this as focusing on...
So it does work for that.
It does. But the author emphasizes that physical interception hits a hard, insurmountable limit. A net can only catch solids. It absolutely cannot eliminate gaseous toxins.
And by gaseous toxins, we are talking about volatile organic compounds, right? The VOCs.
Yes, exactly. Things like formaldehyde off-gassing from pressed wood furniture or toluene from fresh paint, chemicals from your daily cleaning supplies.
Oh, wow.
Because these are gases at room temperature, their molecular size is far, far smaller than the microscopic holes in even the finest HEPA filter.
That makes perfect sense. Using a HEPA filter to stop a gaseous VOC is basically like trying to catch smoke with a tennis net.
Yes.
It doesn't matter how expensive the tennis net is, the smoke just drifts right through the gaps.
That is an excellent way to visualize the mechanics at play. The filter physically cannot stop it. And this brings us to what the author calls the second line of defense, which introduces an incredibly grim biological consequence.
Yeah, here's where it gets really interesting, and frankly, quite dark.
We have to remember the context of modern luxury homes here. They're built to be perfectly sealed shells to maximize climate control efficiency.
Right, you mentioned the airtight doors, zero drafts, and windows that rarely ever open.
Exactly. So when those gaseous VOCs slip past the tennis net of the HEPA filter, they enter a sealed vault.
The pollutants have absolutely nowhere to escape.
They're just trapped in the living space. And because the expensive machinery failed to filter them out, the author argues that the ultimate, final biological filter for the house becomes the living organisms inside it.
The author uses the phrase human air purifier, which just stopped me in my tracks. It is such a chilling concept.
It really is. The source outlines this continuous causal loop. The machine pumps in air, completely failing to stop the microtoxins.
Because it's just a tennis net.
Right. Those toxins then saturate the sealed room 24 hours a day. The humans breathing that air, so the homeowners, their children, their guests, they act as biological sponges. Because human lungs possess immense surface area that is specifically designed to absorb gases into the bloodstream.
So our immune systems, our blood, and our lungs are actively pulling the formaldehyde and toluene right out of the ambient air.
The human body essentially processes the toxins the machine missed.
That is terrifying.
And the tragic irony the author highlights is that as the occupants continually absorb these invisible toxins, which, by the way, the text links to the gradual development of chronic illnesses, the ambient air in the room actually measures as cleaner on a standard particulate sensor.
Wait, really?
Yes, the room seems purer because the human beings basically did the heavy lifting of the filtration.
It's absolutely devastating when you frame it that way. You think you are buying a wellness upgrade, but you are unwittingly paying to turn your own family into the system's last line of defense.
It's a heavy realization.
But wait, I have to ask a practical question here.
Hmm.
If these systems were originally built for giant skyscrapers with massive utility floors, where on earth do interior designers even put all this heavy machinery in a normal family home?
Well, this raises an important point about architectural compromise, which is actually the author's next major target. The source points out a severe spatial contradiction here.
Okay, what do you mean?
Well, standard residential buildings, even ultra-luxury apartments, do not have dedicated mechanical floors. They have limited floor-to-ceiling heights.
Right, so to fit a machine the size of a large suitcase, plus all the thick, sprawling ductwork required to pump air to every single room, you have to find space that literally doesn't exist.
Which forces the interior designer to drastically alter the foundational architecture of the home. To hide the bulky equipment and the whole maze of supply and return pipes, they have to build extensive drop ceilings or false ceilings.
They literally have to lower the roof over your head.
Consider the absurdity of that trade-off. The author notes that wealthy homeowners pay an absolute premium for physical space, right? For airy, voluminous rooms with high ceilings.
Yeah, that's like the definition of luxury real estate.
Exactly. Then they actively spend thousands of dollars more to slash their own headroom, creating this oppressive, low-ceiling environment.
Just to fit the pipes.
Yes. They completely compromise their luxury aesthetic to hide a machine that, as we just established, totally fails to catch the most dangerous chemical gases.
Why do we do this? Like, why are we so easily seduced by the marketing of smart tech that we would permanently shrink our own living spaces?
If we connect this to the bigger picture, the source suggests it is a symptom of a modern illusion. We prioritize the idea of high-tech optimization over foundational living quality.
That makes a lot of sense.
We are so willing to accept a structurally inferior, cramped physical environment if a glossy brochure convinces us that an app-controlled machine makes the house smart.
We are sacrificing the very thing that makes a house feel grand just to accommodate the ductwork. And speaking of the ductwork, the author argues that ruining the ceiling height is actually the least of your worries.
Oh, yes.
The hidden threat inside those ducts is apparently the most dangerous part of this entire deep dive.
This is the absolute crux of the author's mechanical engineering critique. To understand the danger, we have to look at how residential construction vastly differs from commercial installation.
Okay, how so?
Well, in a commercial warehouse or a big box store, ventilation systems utilize hard, galvanized steel ducts.
Like the massive silver rectangles you see exposed in the ceiling of a supermarket.
Exactly those. Due to their rigid metal construction, they can actually be maintained. Commercial cleaning crews regularly send specialized treaded robots with aggressive mechanical brushes down those metal shafts to scrub the interior walls and vacuum up debris.
But you can't exactly put massive steel rectangles inside the drop ceiling of a residential bedroom, right?
No, you cannot. A residential ceiling is full of obstacles. You've got structural beams, electrical conduits, plumbing pipes, tight corners.
It's a mess up there.
It is. Installers are forced to snake the air pathways through a very complex maze. And because rigid metal won't bend, the industry relies on flexible pipes.
The text mentions aluminum foil soft ducts and plastic corrugated pipes.
Right. Those flexible materials solve the routing problem, but the author argues they create a fatal maintenance flaw.
How so?
Corrugated pipes are entirely composed of ridges, valleys, and deep internal folds. Furthermore, the material itself is incredibly fragile.
Okay, I have to push back here for a second because millions of homes have these systems. Building codes in many modern cities actually mandate energy-efficient ventilation. Are you telling me every single contractor and city planner is getting this wrong? Or is the author just describing a rare worst-case scenario? Like, can't we just clean the residential ducts?
The author's argument relies purely on physics and material science to explain why we cannot. If you attempt to send a high-speed mechanical spinning brush down a fragile corrugated aluminum or plastic tube, the brush will instantly catch on a ridge and just shred the material.
Oh, wow.
And if you try to use high-pressure water or chemical foams to flush it out, the thin walls will just puncture.
And if you puncture an air conditioning duct hidden behind your drywall,
you trigger a slow-motion catastrophe. You create these invisible air leaks, allowing condensation to drip silently onto your electrical wiring and your custom woodwork.
that sounds like a nightmare.
Because of this extreme fragility, the author states plainly, residential soft ducts are installed only. Once they go in, they are permanently, completely uncleanable.
Okay, so we have dozens of meters of uncleanable, ridged plastic tubing hidden in the ceiling, carrying air 24/7. What happens over time? The source lays out a timeline that honestly reads like a biological horror story.
The decay is inevitable, but it is slow. The author notes that for the first 1 to 3 years, the system appears to function perfectly.
Right.
The homeowner diligently changes the HEPA filter on the main unit, they listen to the quiet hum of the fan, and they feel incredibly secure about their family's health.
Ignorance is bliss. But then we hit year 5.
By year 5, thermodynamics and biology take over. The source specifically points to Taiwan's highly humid climate as a prime example of subtropical challenges, but it applies to many places.
Okay, what happens at year 5?
Think about the physics of the duct. You have cold, climate-controlled air rushing inside this thin plastic tube, while the stagnant ambient air trapped in the dark ceiling cavity outside the tube is often warm and humid.
Ah, that temperature differential creates condensation. It's like a glass of ice water sweating on a hot summer day.
Exactly. Water begins to pool in the deep ridges and valleys of that corrugated pipe. And simultaneously, the microscopic dust and biological matter that inevitably bypassed the main filter, they settle into that moisture.
So you have a dark, enclosed space, a constant supply of water, and organic dust.
You have engineered the perfect incubator for black mold, dust mites, and bacterial colonies. By year 5, the interior of those hidden pipes begins to resemble a literal swamp.
That is so gross. And then we reach years 10 to 20.
This is the author's ultimate nightmare scenario. At this advanced stage, the heat recovery ventilator has fundamentally inverted its entire purpose.
Because it is no longer an air purifier.
Right. It is a permanent toxic source.
Because all the fresh air from the outside has to travel through that swamp.
Consider the mechanics of it. A homeowner could spend thousands of dollars upgrading the main unit with a hospital-grade perfect HEPA filter. The air leaving that main unit might be perfectly sterile.
Right.
But to reach the master bedroom, the nursery, or the living room, that sterile air must forcefully travel through dozens of meters of rotting, mold-infested, completely uncleanable corrugated pipe.
So the airflow is actively picking up mold spores and bacterial off-gassing from the duct walls and just blasting it directly into the sealed living spaces every single minute.
The system essentially guarantees that secondary pollution is continuously distributed throughout the home. And the author highlights the sheer hopelessness of the architecture at this point, calling it a dead-end structure.
Because you can't clean them and you can't reach them.
The fragile pipes snake intricately behind expensive, permanently sealed drywall and custom wooden ceilings. You cannot simply pull a 60-foot pipe out of a wall like a piece of string.
So what does this all mean for the homeowner?
The only physical method to eliminate the mold-infested duct network is to initiate massive demolition.
Wow.
You have to smash the drywall, tear down the drop ceilings, and completely destroy the million-dollar interior decoration of the home just to rip the poisoned plastic out.
It is the ultimate tragic irony. The analogy that comes to my mind is it's like drinking pure, crystal clear spring water through a muddy, unwashed straw.
That's a perfect analogy.
It doesn't matter how pure the water is at the source. By the time it reaches your mouth, it's toxic. Homeowners think they are buying health. They believe they are investing in a wellness upgrade. But according to this logic, they are actively paying to install a permanent, inaccessible biohazard directly into the architecture of their home.
The homeowner's deep desire for a pristine, perfectly controlled environment creates the exact mechanism that poisons it.
Man, this has been a heavy, fascinating ride. Let's synthesize exactly what we've unpacked today. According to the highly provocative essay by Fuqi Wu, installing a heat recovery ventilator in a residential home is essentially a massive IQ tax.
The author's thesis is crystal clear. These systems demand a tremendous upfront financial cost. They force homeowners to ruin their ceiling height and spatial aesthetic. They fundamentally fail to filter the most dangerous, gaseous microtoxins leaving human biology to do the work.
Which is horrifying.
And ultimately, the laws of physics dictate they will become an uncleanable, mold-infested secondary pollution source hidden right there in the walls. All of this immense structural cost is endured for the sake of minor electricity savings that were originally meant for corporate skyscrapers.
It's a devastating critique of a technology that is usually universally praised as a green, healthy solution.
What's really fascinating here is how the author defines the absolute baseline for true air purification.
Oh, right. What is that baseline?
According to the source material, authentic purification must be direct, it must be cold and physical, and it must leave absolutely zero dead zones for secondary pollution to fester.
Zero dead zones.
Exactly. If we take anything away from this deep dive, it's the immense value of critical thinking. We must rigorously evaluate high-tech home upgrades that claim to digitally solve what are essentially natural biological needs. We cannot blindly trust the brochure.
It really makes you question the narrative of modern luxury, which brings us perfectly back to where we started. We opened by talking about the human desire to build a perfect, sealed vault.
Right, that illusion of total control.
The belief that if we just add enough machinery, we can master our environment. So I want to leave you with a thought to mull over, especially if you hear a fan humming above you right now.
It is a vital question for anyone planning a home.
If our modern obsession with perfecting and controlling our indoor climate leads us to build increasingly complex, sealed-off environments that eventually poison us from the inside out, should we fundamentally rethink what modern architecture is even aiming for?
That's the real question.
What if the ultimate luxury isn't a complex network of hidden machines, plastic tubes, and artificial lungs? What if true luxury is simply a home designed to breathe naturally with the outside world? Thank you for joining us on this deep dive into the hidden mechanics of home ventilation. We'll catch you next time.